Okay, so we have a line of charge and it's sweeping out a total angle of 60 degrees. So we're investigating the electric field at this point P, which is a distance r from our line of charge. And I'm telling you that the total charge of that line is given to you as positive Q. So we start by investigating a very small sliver. And we say that that sliver has a total charge dq. Okay, that little sliver is also a distance r from point P, and it exerts an electric field dE like this. Now, let's put an axis up here. Because of the symmetry of this line of charge, we have no dEx, because if I investigated a sliver on this side, the electric field would be pointing down like this. The x's would cancel, leaving me only with an electric field in the y direction, dEy. Now, this angle right here is theta. dEy is going to be dE cosine of that angle. Now, what is dE? dE is 1 over 4 pi epsilon naught times dq all over r squared, where dq is the total charge of our little sliver. Now, how do we get dq? What we do is we relate dq, the total charge of the sliver, to the total charge of the whole line. So lambda, or the linear charge distribution, is the total charge over the total length. But I did not give you the total length of this line. I only told you the angle of one side, which you can infer that that's the same angle over here. So the total angle that it sweeps out is 60 degrees, which is pi over 6. So what you can do is figure out the arc length of this line. So lambda becomes q over radius times the angle that it sweeps out, which is pi over 6. So rewriting that to make it look a little nicer, lambda is 6q over r pi. Now, how do we relate this to dq, or the tiny charge of my tiny sliver? Well, lambda is proportional no matter what size of object you're talking about. So this is dq over the length of my tiny section. Well, if you look at this, I sweep out a very small angle in here, which I'll call d theta. So total charge over the total length of my section would be the arc length of my little section, which is r times d theta. So these two are both lambda. Set them equal to each other. So 6q over r pi equals dq over r d theta. Solve for dq. Multiply both sides by r, and my r's cancel out. So dq becomes 6q over pi times d theta. Or you can think of this as the total charge, q, divided by the total angle. So you would divide by pi over 6, which is like multiplying by 6 over pi. So now we know dq, which we can replace here. And this is dE, which we can put in here. So let's rewrite dEy with dE and dq substituted in. So dEy becomes 1 over 4 pi epsilon naught times dq, which was 6q over pi, and then 1 over r squared times cosine theta d theta. Now, this might look gross, but all of this is constant. So when I integrate both sides, all of this comes out. Now, when we integrate, we need to talk about our limits. here's how we're going to do this. Here's our line of charge, and here's point P. Make this center part of your line of charge. Think of that as 0. I go out 30 degrees in either direction. So whenever I go out to here, I would make this pi over 6, which means that when I come out to here, this is negative pi over 6. So my limits of integration would be from negative pi over 6 to pi over 6. Now, whether you do it that way or you go pi over 6 to negative pi over 6, it doesn't matter because this equation is really giving you the magnitude of the electric field. It is your job at the end of this process to figure out the direction. So let's integrate both sides. I get EY equal to, I'm going to simplify this just a little bit. So I've got 6 over 4, which is 3 over 2, 3q over pi times pi, which is pi squared, epsilon naught, r squared. That's my constant. The integral of cosine is sine. And I'm going to evaluate sine of theta from negative pi over 6 to pi over 6. Okay. So, EY. Write all that constant jazz down again. 2 pi squared epsilon naught r squared. Sine of pi over 6 is going to be 1/2 minus sine of negative pi over 6 is negative 1/2. 1/2 minus negative 1/2 just becomes 1. So my electric field, the magnitude, is 3q over 2 pi squared epsilon naught r squared. Now, what about the direction? My line of charge, I told you, was positive q. So whenever you're investigating a point P, you use a positive test charge. So if this were positive, the electric field would be directed down. So you could say the electric field is 3q over 2 pi squared epsilon naught r squared down, or away from your line of charge. So that's a brief video tutorial for electric field due to a bent line of charge. The main thing to take away from this: when you are working with a continuous charge, if you are a distance r away and you know the angle that it sweeps out, you're going to relate dq to the total charge. So q over L is lambda. This lambda is related to dq. So you could do dq over your very small length, which in this case is r d theta. The two are equal. Now, when you're figuring out your limits of integration, make this center point 0. Go down. So let's say this was 45 degrees, and this one was also 45 degrees. Your limits of integration would be negative 45 degrees to positive 45 degrees. Make your center point 0, go up, and then go down.